Section 6.3, Finding Probabilities for the Normal Distribution. So to compute probabilities for a continuous random variable involves computing the area between the distribution curve and the axis. So once upon a time, this involved computing z-scores and using tables of normal areas. Fortunately, this is a statistics using technology textbook, and so we're going to learn how to use technology to compute these probabilities when we know that the random variable has a normal distribution. So the first technology that we're going to look at is for computing probabilities for normal random variables. And again, our main technology that we're going to be using here is going to be our calculator, because it's really no faster to do these in StatCrunch than on the calculator. And the calculator is what we will have access to on the unit exams and departmental final. But again, it is nice, if you already have it open on your computer screen, to get these probabilities there and to actually see some pictures that go along with them as well. So in StatCrunch, just like with the binomial, we would click Stat and go into Calculators. And in that list, Normal is one of the options that is there. A pop-up window would open where we would enter a mean and a standard deviation. And then we would enter the probability that we want, and then we would push compute, and our answer would pop up in this box here. So for example, let's look at just computing this one in particular here. I'm using StatCrunch. So if we go into StatCrunch and we click Stat and go into Calculators, there's a bunch of different distributions here. So like we said earlier, there are lots of other discrete and a lot of other continuous ones. Our main focus in this course is going to be binomial for discrete distributions and the normal distribution for continuous random variables. So in this list, we're going to pick normal. And a pop-up window comes open that I'm going to slide over here. And so in for the mean, we would type whatever the given mean was in the problem. I'm just going to use the one that is on the book there, which was 272, and for the standard deviation it was listed as a 9, and we wanted the probability of getting, alright, so again in here we have less than or equal to or greater than or equal to. Remember, for a continuous random variable, it doesn't matter if it's strictly less than or strictly greater than. Whether the endpoint's included or not doesn't affect the probability, so that's why those other two options aren't there. If you wanted between values, you would push between, and then you would get between values. And again, it already includes the endpoints because, again, even if they're not included, again, the probability answer is still the same for a continuous random variable. So I'm going to go back and click Standard here. So we want x less than or equal to, and then again on the textbook page there was a 260. So a mean of 272, a standard deviation of 9. What's the chance of getting an x value to the left of or equal to 260? So if we hit compute, we can see that it gives us the distribution curve and shades to the left of, because we want the x's to the left of 260. And again, this 0.09121122 is the area of that shaded region. On your book page there, it also says that if you want those tick marks to be 1, 2, and 3 standard deviations away from the mean instead of just the random ones that are here, we can click this button. Okay, it will then recenter the curve or the curve was already centered at 272. It just didn't have a marking at 272. So now we've got our mean and our 3 standard deviations to the right and our 3 standard deviations to the left, like we looked at in the last section when we were getting approximate probabilities for these things. But we can see here with the shading here that 272 is not exactly, 260 is not exactly 1, 2, or 3 standard deviations away from the mean, which is why we're using this normal calculator. In the background, it's actually doing the calculus to compute this area that we have here. But as I said earlier, the main technology that we are going to use throughout this unit is the calculator, because it's just as fast as StatCrunch. StatCrunch saved us a lot of time in the last unit because we didn't have to input all of the lists of data. In these sections, we aren't going to have lists of data as we're dealing with these probability distributions. So in the TI-84, we would push second variables to open up this distribution menu. And in here, the one that we're looking at for probabilities when we're dealing with a normal curve is normal CDF. So we would push 2 to pick normal CDF. And then we would either have a screen that looks like one of the following. So within your textbook pages, you should circle which one of these looks like your calculator and cross the other one off, because again, it just depends on if you have the older operating system. Yours says normal CDF with an open parentheses and you have a blinking cursor. But if you have the newer operating system, it says normal CDF and then it actually lists the 4 things that it's waiting for you to give to it. So on the calculator, if we hit second and then variables, because above that is distribution in the same color as our second key, it opens up this distribution menu. And of those choices, we want normal CDF, so we would push button 2. Okay. My calculator, you can see, has the newer updated operating system. So in here, I'm going to enter the numbers that are shown on your textbook page there. So we're going to enter in 10. And then for the upper is 20. And then the mean of the distribution was given as 2 and standard deviation of 1. Okay. And so then we would hit paste. We would highlight that and hit enter. Okay, now it looks on screen like the other models of the calculator. So if your screen looked like the one on the left, you would have hit 10, 20, 2, 1, where the comma key is above your 7 key on your calculator. Okay, so once we're all to this point, we would hit enter, and it gives us a probability here. Okay, so now keep in mind the 6.28, a probability can't be 6.28 because it's greater than 1. So this e minus 16 at the end means times 10 to the negative 16th power. So this probability is really, 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 really small. All right, so this previous one, we were finding the probability of getting an x value between 10 and 20 for a distribution where the mean was 2 and the standard deviation was 1. But many cases, as we look at the distribution, where one of our endpoints might be infinity because the curve extends on the x-axis from negative infinity to positive infinity. So if we have an interval where the lower endpoint is negative infinity, we're going to use negative 10 to the 99th power for that. Okay, now that's not what negative infinity is equal to. Okay, negative infinity is not a number, it's just a symbol for as negative as we can go. So on the calculator, we're going to use negative 10 to the 99th power for that. Same with if the upper endpoint is infinity. Again, that also, there's no number equal to infinity, so for statistics, we're just going to enter 10 to the 99th. So these are close enough approximations for the infinities when we use them in statistics. And then we would highlight paste and push enter. Okay, so here where it says calculate, that's actually not what that says here. That would actually, so if you have the newer operating system, you would have to hit paste and hit enter, and then your screen looks like this one, and once we've got those in, we would hit enter again to get that final end result.